Assalamu alaikum dear friends, how are you today? My today's lesson is about number of points between two given positions are members of a given matrix and their indices, that is row numbers and column numbers of all those positions or points. So let's begin. Bismillahirrahmanirrahim. These are called matrices in our program. This matrix has 11 rows as well as 11 columns. You can find out the number of points that fall on these four lines. Also, on these four lines, here or here. You can get the numbers or the indices of all these numbers that fall on these lines. And then you can apply a function. For example, you can find the mean of those numbers. There can be other possibility like this one. So, what numbers fall on these lines? 17, 5, 2, 9, 4, 6, 9, 10, 3, 16, 6, 18, and so on. And then on this diamond and inner diamond, this one, this one, and this one. So if you see, this diamond shape structure has 3, 3, 5, and 5 numbers. Now we suppose that we have a matrix of 11 into 11, that is with 11 rows and 11 columns. In our today's example, we will consider each member of a matrix as a point, not a number. The numbers examples will be discussed in my next video about my function. So this is the first column, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and for example, this is 11th number column. These are considered as rows. So row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th, and 11th row. Each of these points has their own indices, that is row numbers or column numbers. For example, this point has indices of 4 and 9, that is row number 4 and column number 9. And suppose there is another point here, and that point's indices are 10 and 6, that is row number 10th and column number 6. Now suppose we want to draw a line from point number 1 to point number 2, and suppose we are interested in finding the number of points that fall on this line. If you see a total of 4 points, their indices are like you can see in the slide. So there are a total of 4 points that fall on this line. Now if, for example, we have another point here and we want to continue the line to this third point, and then we have another point, we connect that point to the next point and then back to the first point. And then if you see, there are other points through which our line passes through, and the indices of all those points are given in the slide, you can see, and now the number of points becomes 12 on all those 4 lines. We have 2 questions to answer. If we draw a line between 2 points of a matrix, between 2 members of a matrix, then 2 kinds of information we may be interested in. That is, how many points does this line or lines passes or cut through? That is the number of points. The second question or the second thing that we may be interested in are, what are the coordinates, that is the row numbers and column numbers of all those members, all those points. You can find the solutions or the answers of these 2 questions by drawing a line between the 2 points and count the points manually. Or you can use a mathematical formula to calculate the number of points that fall on that line. For example, I have used HCF or GCD formula in my functions. The third is use my functions. One of them is called endpoints, which will calculate the number of points that fall on the 2 or 3 or 4 lines. And another function is mtrx indices that will calculate the indices of all those points that fall on those lines. these values mean the list of the given indices, the endpoints, in between which you are drawing the line, or you are going to connect those points through a line. And these values must be in the form of a list. For example, here C5, 4. This is the first point and this is the last point. And we are going to draw a line from this point to this point. And then we are interested in finding the number of points that fall on this line between these 2 points. Now let's take examples of 2 points. So first, the horizontal line. How many points fall on the line that connects the 2 points of a matrix? That is, for example, one point is at 6, 1, that is row number 6 and column number 1, and the other point is at row number 6 and column number 11. Then, for example, this is our first point, which is at 6, 1, and this is our second point, which is at 6, 11. Now let's connect this point with the last point and count the number of points on this line. We'll see that we have 11 points that fall on this line. These are the indices. So how will you find out the number of points as well as the indices of all those points using my functions? These are 2 functions that I have created through which you can find out the number of points and matrix indices. And this is the way, or this is the syntax you will have to write them in your R program. This one is the first point, that is 6, 1. And this one is the last point, that is 6, 11. This function will find out the number of points, that is 11. And the second function will find out these indices given here. Okay, now let's take another example of a vertical line. So how many points fall on the line that connects the 2 points of a matrix from 1, 9 to 11, 9? For example, this is the first point at 1, 9, and this is the second point at 11, 9. We are connecting these 2 lines. Then we count the number of points. They are 11. And these are the indices of all those points. And this is how you will find out the number of points and their indices using my 2 functions. Now this time a diagonal line. So how many points fall on the line that connects the 2 points of a matrix from 11, 1 to 1, 11? This is the first point. And this is the second point. You connected these 2 points through a line. And the first point is at 11, 1, that is row number 11 and column number 1. The second point is at row number 1 and column number 11. A total of 11 points fall on this line, and their indices are and these are my functions which will calculate the number of points as well as their indices. Now let's take example number 4 of a diagonal shorter line between 2 points, that is 7, 6 to 3, 10. This is our first point at row number 7 and column number 6. Another point is at row number 3 and column number 10. You draw the line and then you count the number of points. They are 5 points. So a total of 5 points fall on this line. These are the indices of all these points, and this is how you will calculate them in our program. Let's take example number 5. A line between 2 members of a matrix, that is first member is at 7, 2 and the second is at 3, 8. This is the first member at row number 7, column number 2. This is the second member at row number 3, column number 8. You draw a line between these 2 points and you count the points. There are 3 points that fall on this line, and these are the indices of all these 3 points. This is how you will calculate them in your R program using my functions. Co-prime points. First, what are co-prime points? If a line that connects 2 points of a matrix doesn't pass through any other point except those 2 points, then they should be referred to as co-prime points, just like prime numbers which are only divisible by self and 1. For example, these 2 points, one is at row number 3, column number 1, the other is at row number 1 and column number 4. You connect them through a line and you see that the line that connects these 2 points doesn't pass through any other line. So we have only 2 points here. Again, we have another 2 points, another 2 members, one at 7, 6, another at 10, 10. Connect them through a line, and again you see it doesn't cut any other point except these 2 points. So again we have only 2 points here. The third example, a line between position number 4, 2 to position number 1, 9. Again, this line doesn't cut any other points except the first and the last point. That is only 2 points. So here again, these 2 points are co-prime points. Now let's take examples of 3 points. 3 points with open ends. For example, how many points fall on the 2 lines that connects the 3 points of a matrix with open ends? That is, first line from 10, 9 to 4, 9, and then from 4, 9 to 4, 1. For example, your first point is at 10, 9, second point is at 4, 9, and third point is at 4, 1. You connect the first point to the second and then second to the third. And then you count the number of points that fall on these 2 lines. So we have a total of 15 points. And you can find out their indices and the number of points using my functions like this. Here you are using list of the 3 points, not all the points, only 3 points. This is the first point, 10, 9. Here, this one. This is the second point, 4, 9. And this one is the last point here. You will have to combine all these 3 points with a list function. The same is the case with matrix indices. Now let's suppose you have 3 points with closed ends. So how many points fall on 3 lines that connects the 3 points of a matrix with closed ends? That is, the line goes from this to this, and then this to this point, and then goes back to the first point, that is 10, 9. So you have first point at 10, 9, second point at 4, 9, and third point at 4, 1. You connect the first point to the second, second to the third, and the third back to the first point. So how many points fall on these lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So a total of 16 points fall on these 3 lines. You can calculate them in R using my functions like this. You will have to combine all these 4 points in a list. Remember that you will have to use this first point positions twice, one at the beginning and second times at the end of the list. So 10, 9 will come twice because you are using a closed cycle. Examples of 4 points. 4 points with open ends, for example. How many points fall on the 3 lines that connects the 4 points of a matrix with open ends? For example, from 10, 9 to 4, 9, then to 4, 1, and then to 10, 1. For example, your first point is at 10, 9, second is at 4, 9, third one at 4, 1, and fourth point is at 10, 1. You connect the first point with the second one, with third one, and then fourth one. Now, the number of points, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So a total of 21 points fall on these 3 lines. How will you calculate in your R? You will have to make a list of all these 4 points. That is 10, 9, 4, 9, 4, 1, and 10, 1. Now let's suppose you have a closed loop of 4 points. That is your first point at 10, 9, second point, third point, and fourth point. Now you connect your first point to the second, second to the third, third to the fourth, and fourth back to the first point. Now how many points? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. You can calculate them using my functions like this. Here also, you will have to give this first point twice, once at the beginning and then at the end, because this loop is closed loop. This will then calculate the number of points, and this one will calculate the indices of all these points. Now let me show you the codes of these functions, and then let me apply those functions on these points. This is the function about HCF. This function calculates the HCF for you, and you need this function for my two functions, that is endpoints and MTRX indices. You must type this function in your editor and then run before you type the other two functions in your editor and run them. So first you will have to type this function. And then this is the actual function, that is matrix indices, which finds out the indices of the points that fall on those lines. So this is the code of this function. And here in this function, I have used the HCF function, you can see here, which is used inside this matrix indices function. Okay, now the third function, number of points. This is simple. Here, this function needs this matrix indices function, the above function. That was the actual function I coded. You just need to find the length of matrix indices. Once you find the indices of all those points, then it's easy to calculate the number of points. Just find the length of that list, above function's result. Now let's apply our two functions on those examples that I gave in my slides. So the first example was about 2 points at 6,1 and the other one was at 6,11. So this example 1 will be run and it will find that the number of points between these 2 points are 11. What are the indices of function? It will find the indices of all those 11 points. Then this was our example number 2 here, this one. Now let's run this example. Here again we have 11 points and their indices are 19, 29, 39, etc. till 11, 9. The third example given in the slides was this one. Again 11 points. This was the diagonal line, and what are their indices? These are the indices. Okay, let's come to the example number 4. This was a shorter diagonal line, 5 points with these indices. Example number 5. This was a further shorter diagonal line, and these 3 are the indices of these 3 points. Then this was, I think, the co-prime point with 2 points, one at the beginning and one at the end. And what are their indices? 4, 2 and 1, 9. This was another example of co-prime points with 7, 6 and 10, 10 matrix indices. Now let's come to the 3 points with open ends. These are the 3 points, 10, 9, 4, 9 and 4, 1. So how many points? 15 points fall on these 2 lines that connects these 3 points. And what are their indices? Just run this function, this one, and it will find all the 15 indices. That is, this is the 15th number and this is the 15th number indices. We have 1, 2, 3 points, and this one is the first point. Again, you need to write because you want to calculate the number of points for closed ends. Run this function. There are 16 points here. And what are their indices? These are the indices, a total of 16 indices here given. This represents the row number and this one column number. Then let's come to the 4 points with open ends. A total of 21 points fall on these 3 lines that connects these points together. And what are their matrix indices? 21 indices given here. Come to the 4 points with closed ends. This example. A total of 28 points fall on these lines that connects these points. And what are their indices? These are the 28 indices of all those points. Okay, once you find the indices of all those points of the matrix, then it is easier to get the values of all those indices using the extraction formula in R. That is, just type the name of the matrix and then for example, these are the indices 10, 8. So 10 and 8. So these are the 2 indices. This will get the value that fall at this point in the matrix. Okay, then how will you find all the values of all these 28 points? You will have to use your looping function, that is for loop or while loop. It will extract all the values from the matrix that fall on these points. Okay, there are some important points you must remember. To count the number of points, not numbers, manually, you must take care of the following points. The distance between consecutive points must be identical vertically as well as horizontally. That is, these distances are not equivalent, while distances in these points are equivalent. The distances here are greater, while the distances between these two are smaller. Correct way to draw your matrix. However, here you can see the distances between all the points are equal horizontally as well as vertically. With increase in dimensions of the matrix, the point size should decrease. It's not a good way to have points with bigger size. You must use smaller size points. The line width should decrease with increase in the dimensions of the matrix. That is, this is not a good choice to use a thicker line. However, a thinner line is better than the thicker line. The distance between points should increase with increase in dimensions of the matrix. That is, you must have greater distance between consecutive points rather than a closer distance. The thinner the line, the better the resolution. For example, let's first take a thinner line. You can see this thinner line only connects 2 points, and there is no other point that it cuts through or passes through. However, if you use a thicker line to connect these 2 points, it will also cross false points. For example, here you can see this point. This is a false point. This is not a point that is in between these 2 points. As you are using a thicker line, that's why it cuts this point as well as this point as well. And also it touches this point as well as this point. So these are called as false points. They are not actually on the line. Now let's come to the smaller points versus bigger points. The smaller the points, the better the resolution. For example, here you connect these 2 points and you see it doesn't cut any other point in between these 2 points. If you use bigger points, then it may touch other points on the way, which are not the actual points that fall in between these 2 points. Your result or your calculation will be inaccurate if you use thicker lines or bigger points. Another is the closer versus farther points. The farther the points, the better the resolution. This resolution is better as compared to this resolution. Now let's see. As you can see, these points are closer, so due to their closeness, this line is also touching these points, which are not the points that should be touched. The points are farther from each other. These false points will not be touching your line. So your results will be accurate, or the resolution of your result will be better. I'm dedicating this function to all my subscribers on YouTube. Thank you for subscribing my channel, dear subscribers. And thank you for watching this video as well. Take care. Bye.